Welcome viewers. Today we will discuss an important topics which we have introduced in engineering mechanics, and it's also relevant to the solid mechanics series. So let's move. We will see the method of joint. So today's topics is the method of joint. Let's jump to the uh, numerical. Before that, let us discuss what are the uses and what other options we have to do such things in different way. So let's move. There are two methods, method of joints and method of sets. Obviously, you heard these two terms in engineering mechanics or solid mechanics subjects. These uh, methods actually used in trusses to find out the axial forces, the magnitude and the nature of forces. Means the value of forces coming and the forces of tension or compression. You can find it by this method. So we will discuss method of joints. If the number of members are less in a truss mechanism, a truss structure, you can go for method of joint. Otherwise, if the combination of the structure or truss or frame consists of a numerous number of members, means if there is a significant amount of member which cannot be evaluated by method of joint, because method of joint itself a joint to joint technique to find out the forces, whereas method of section is a shortcut method to find out forces over a specific member. So here is the catches, you can read it out, what should be remembered to proceed according to this method. So let's move to the method of joints. Okay, so let us take an example. What are we? So basically method of joint is a process to follow the forces joint to joint, and these forces over joints will decide the forces acting or bearing by the members. Okay, so here you can see there are four joints, A, D and C, lastly B. There are four joints. Joints are the point or connecting node. Actually it's a node where two member connect to each other. Remember it, if there is a joint, then there must be two members. A joint or node cannot be formed by using one single member. There must be two members joining to a single point, that is called joint or node. What we can see here, there are support system. Here you can see roller support and there is a hinge support. Okay, we all know about support system and the members combination. This whole type of mechanism, we called it, if it is subjected to some load and it can bear this loaded at an extent of its elastic limit, that then we will call this mechanism as a structure. Okay, so look at this problem. There are some event data you can actually see here. So the breadth or depth of this mechanism is 1.8 meter and length is 2.4 meter. That means it's 2.4 automatically and it's 1.8 meter. We don't know the length of this diagonal. We can find it by using trigonometry. We will find it on proceeding. So let's move to the method of joint uh, calculation process. Okay, so let's move. So here you can see all the necessary details given by the formula. Here is the additional. Whenever we go for FBDs, we can have these additional parameters, that is the angle between AB and BD. And because of this hinge support provided in A point, there are two reactions, that is vertical reaction. One is vertical reaction and second one is horizontal reaction. Okay, and because of this roller support, there will be only one reaction, that is vertical reaction. There will be no horizontal resistance, and the external force is given by 2 kilonewton. Okay, so horizontal forces we are representing as horizontal reaction actually is represented as AX, and vertical reaction over point or joint A is AY, and vertical reaction over joint B is BY. Now support reaction we have to find out first, because without support reaction we cannot set a joint, we cannot set a joint, we cannot set a joint, and we cannot move to the further joint. So the beginning point is to find out the support reaction. Okay, now there are some assumptions. First assumption is all the members is subjected to tension. We will consider if a member given or subjected to some forces, then the internal axial forces over member, the nature of the forces is tension. So tension force we consider is as positive. There is a there is an assumption like that, you have to consider it as the axial forces coming is tension. If the data is coming in negative, if the after the calculation if the data is coming negative, then we can conclude that the member is in compression. The member is in compression. Then our assumption is not right. Back to the support reaction. How we can find it? First of all, we know about the equilibrium equation, that is summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment is equal to 0. We will use this 2D equilibrium equation to solve this, because this problem is given in 2D. So